Welcome to Growing Up Digital, Lesson 1. This video will focus on computers and how they operate. Today, computers shape our lives more than any other technology. Thanks to miniaturization and networks like the internet, microprocessors and digital data are all around us. From the massive secret servers that run Google to pocket-sized laptops, from satellites in outer space to medical devices implanted inside bodies, computers are everywhere. More than just a tool for engineers and mathematicians, these increasingly complex digital machines are now embedded in every part of society and culture. Access to a computer and the internet has become an essential part of life and work in the developed world. For years, vast flows of digitally encoded data have driven networks of communication, transportation, and commerce. Only more recently have digital interactions become personal. Since the late 1990s, the internet has been a major social and cultural site, an instant and endless supply of knowledge, a democratic medium for self-expression, and an intense political arena. Digital systems deliver everything from YouTube videos to guided missiles. But still, many people have no idea how computers actually function. How does email or the internet work? Ask a coworker and they'll likely say, I don't know, it just does. This black box understanding of computers and other important digital systems is not beneficial. In today's increasingly technological digital world, it's more important than ever to understand where computers come from, how they work, and what impact they have on society. At their most basic level, computers are machines that can store, retrieve, and manipulate information. Since things like videos and music require large amounts of information, the most efficient way for a computer to operate is by using a system of electric pulses to represent numbers. This is referred to as digital code. Computers function by converting information from images, text, sound, and video into digital code. Named after the Latin word for finger, digitus, digital code is a convenient way of expressing information using only numbers. Here's a simple example of how this works. Consider the following code. Here, A equals 1, B equals 2, C equals 3, and so on until Z equals 26. Using this, we can create a digital code for the word job. J equals 10, O equals 15, B equals 2. So job can be encoded digitally as 10, 15, 2. By the same token, computers capable of millions of calculations per second can take complex things like images, text, sounds, and movies and encode them into strings of numbers. They can store, send, or display this data. The number system we're most used to, called base 10, is a direct result of human biology. We happen to use 10 digits, 0 through 9, to express numbers because we have 10 fingers. But numbers can be expressed in many different ways. Some people are used to seeing long strings of ones and zeros associated with computer data. This is a form of digital code called binary. Binary simply means two choices, here, 1 or 0. This is known as base 2. We're used to seeing numbers expressed in base 10, where we use a group of 10 possible digits, 0 through 9, to express every number. In base 2, or binary, every number can be expressed using only two different digits, a 1 or a 0. Since computers operate using electrical pulses, coding using the two digits of base 2 binary code is more efficient than using the 10 digits of base 10. Computers store binary data using a difference in electrical voltages, on or off basically. One voltage level is programmed to represent 1, while the absence of a charge represents 0. For the computer, this system is very simple, 1 or 0, on or off. Each 1 or 0 is known as a binary digit, or bit. Strings of 1s and 0s that represent one letter are called bytes. Bytes are made up of bits, and a byte is usually made up of 8 bits. The standard code through which a byte is linked to a specific letter is called ASCII, which stands for American Standard Code for Information Interchange. ASCII codes are based on the Western alphabet and are used by computers to display text. All information inputted into a computer is converted back and forth into binary code. When you type a J on the keyboard, the computer receives an 8-bit byte. The byte corresponds to a number on the ASCII chart, the ASCII code, which tells the computer to display the character J. Every computer program works using binary data at its most basic level. As users, we never see the binary data because the computer converts it back into user-friendly text, images, or sound. The most basic attribute of any computer is that it can only do what it has been programmed to do. Computers can only really be programmed to perform mathematical and logical operations. However, modern computers can perform millions of these operations every second, resulting in the complex programs and operations we see on screen. There are two ways of storing and receiving data: analog and digital. Any computer made within the last 40 years is digital. Only early computers were analog. With analog, information is coded by a continuous signal, like a record player's needle sweeping through a groove on a record. The grooves represent an analogy of the original sound waves. The grooves vibrate the needle, creating a signal, which is amplified to reproduce the sound. Digital coding is what we find on a CD or in an MP3. Here the information is broken into tiny bits and is coded as discrete, separate numbers, not as a continuous signal. Digital data has made analog data obsolete because it never degrades, it can be recalled faster, and is easier to transmit. This is important since modern computers are constantly receiving and transmitting data. Digital data has spurred a profound revolution in the way we live, play, and work. We can communicate faster and more easily than ever before, and take large amounts of information anywhere without much effort. Your entire record collection now fits in your pocket. But turning one's physical information into patterns of electricity also allows commodities like music and movies to be copied quickly, easily, and illegally. This has forced artists and corporations to experiment with new ways to sell, distribute, and navigate a new economy based on intangible products.